In this lesson, we're going to be graphing general rational functions, and as we do so, there's going to be some different characteristics of these functions that we're going to be able to pick out simply by looking at and working with the numerator and denominator of the rational function. So if you remember from the first lesson, a rational function is one where there's a polynomial numerator and a polynomial denominator, and that's what this expression is just showing right here. So p of x is just any particular polynomial for a numerator, q of x any particular polynomial for a denominator. Now, the x-intercept of a function like this, okay, the x-intercept is going to be what x value makes the entire function equal 0. Well, if I have a fraction, in order to make that fraction equal 0, I need to make the numerator equal 0, because if I have 0 divided by anything, it's going to be 0. So for my x-intercept, what I want you to jot down here for your notes is that the x-intercept is going to take place wherever the numerator is equal to 0. See if I can get this to work here. Make it a little bit smaller. Turn off our numbers. So wherever the numerator equals 0, that's where the x-intercepts of that function are going to be. Okay. Now, as far as the vertical asymptotes are concerned, it's a little smaller. The vertical asymptotes, if you remember from yesterday, they happened when I was dividing by 0. Remember, I can't divide by 0, so any number that makes my denominator equal 0 is going to not work, which means there's going to be a vertical asymptote there. So, for the vertical asymptotes, jot this down. Wherever the denominator equals 0. Okay, that's where your vertical asymptotes are going to be. Now, when it comes to the horizontal asymptotes, there's some different things that might happen. The horizontal asymptotes really depend on, what is going on with the degree of the numerator versus the degree of the denominator. So in this table that you've got in your notes, you'll notice that it says m less than n, m equals n, or m greater than n. M is the degree of the numerator, or the top. N is the degree, meaning the biggest exponent, of the bottom, or the denominator. So depending on which of those numbers is bigger, or maybe they're the same, there's different things that go on with the horizontal asymptote. If the numerator's degree is less than the denominator's, then y equals 0 is going to be a horizontal asymptote. The idea being that the denominator is going to get really big and the numerator is not, so that's going to be a function that gets really close to 0. Now, if they're the same, my degree, I've got x squared on top, x squared on the bottom, well, then I look at the leading coefficients. That's what this a sub m over b sub n is. Whatever the first numbers that show up in the function on top and bottom, whatever that fraction might be, that's going to be where our horizontal asymptote is. Now, if the numerator is greater in degree than the denominator is, that means there's no horizontal asymptote. Instead, we'd have what's called a slant asymptote. Now, you don't have to learn about that here in Algebra 2. That's something that in pre-calculus you will look at. So, the last thing to make note of here is the idea of holes. There's going to be some functions where holes show up in the graph. It won't necessarily be a vertical asymptote, but there's going to be some number that if I plug it into the denominator, it makes it equal 0. What makes it a hole instead of a vertical asymptote is if I have a shared factor in my numerator and denominator. Now, we'll look at some examples of all these things, but again, you can maybe pause and write that down. There's going to be a hole wherever there's a shared factor in the numerator and the denominator. So, taking a look at our first function. So here we're asked to graph a rational function where m is less than n, meaning the degree of the numerator, in this case the degree is 0, is less than the degree of the denominator, which is 2. So things we're going to figure out. Where are the x-intercepts, where are the vertical asymptotes, where are the horizontal asymptotes, and are there any holes? Okay. For the x-intercepts, and we're going to look at the numerator. What makes the numerator equal 0? Well, nothing. It's a constant. So as far as x-intercepts are concerned, we've got none. Now, the vertical asymptotes are going to happen at the x values that make the denominator equal 0. So if you think about my denominator equaling 0, if I have x squared minus 4 equals 0, just imagine this. If I add 4 to both sides, I have x squared equals 4, and then I take the square root, well, x is going to be either positive or negative 2. So if I plug in 2 or negative 2 into the denominator, it would force me to divide by 0. That's something I can't do. So that means there's going to be vertical asymptotes at 2 and at negative 2. So what I could do is I could actually draw those over here on my coordinate plane. So I'll go ahead and draw in a couple of dashed lines. So negative 2, not easy to do with the mouse, and positive 2. So dashed lines, those are my vertical asymptotes. Now my horizontal asymptote, remember, depends on the degree of the numerator versus the denominator. Well, the numerator is less in degree than the denominator, and our rule from before was, if it's less, then y equals 0 is a horizontal asymptote. So I can put that in right now. Y equals 0 is going to be a horizontal asymptote. I will draw a dashed line along the x-axis to represent y equals 0. Now, from there, I've cut my graph into a couple of sections. Now, my hyperbola is not really going to be a hyperbola. It's just going to be a goofy looking function. At this point, what I would do is graph it using Desmos or my calculator. Now, the last thing that's here, before I show you the graph, holes, well, holes happen when there are common factors in the numerator and denominator. Since the numerator is a constant, there's no common factor here. It needs to be a polynomial factor. So there's going to be no holes in this graph. We'll go ahead and put none right there. I'll show you what it looks like. I put this on Desmos, and here is what that function looks like when you graph it. So negative 2 over x squared minus 4. And notice I've got a branch here, a branch here, a branch here. Notice where we don't have anything existing. At negative 2, there's nothing. And at positive 2, there's nothing. Those are the vertical asymptotes, remember? Now, other things that I have, I said there were no x-intercepts. Well, my graph never touches the x-axis. It gets close to the left and it gets close to the right, which, if you remember, y equals 0 was our horizontal asymptote, so that should make some sense. If I scoot out a little bit, zoom out, you'll notice it's really close to the x-axis on both sides. We'll never quite get to 0. Okay, so there's our first one. We'll look at a couple more in another video.